Welcome back to trigonometry. This is part 9. In this video, we discuss few good questions involving trigonometric identities. We have already learned the important identities in grade 11 and grade 12. Tan theta equal to sin theta or cos theta. Sin square theta plus cos square theta equal to 1. Again, the double angle identity sin 2 theta equal to 2 sin theta cos theta, and cos 2 theta we have 3 options. We will make use of all these informations in the questions involving identities. We make use of them in the identity questions. Now, I'm going to give you a few tips to prove the identities. First, we have left hand side and right hand side in the question. Split. You start either from left hand side and prove it equal to right hand side, or use the right hand side first and prove it equal to left hand side. Now, you can also use these basic identities, double angle and compound angle formulae, addition, subtraction or fractions, okay, simplify. Then also we can factorize if necessary. Okay? That's how we develop these questions. Prove that 1 over cos square theta minus 1 equal to tan square theta. So we start with the left hand side. 1 over cos square minus 1. So when we have fractions, usually we take the LCD, that is cos square. Then we simplify the numerator 1 minus 1 times cos square. We remove the bracket. 1 minus cos square theta over cos square. 1 minus cos square is sin square. We have a identity, the well-known identity, 1 minus cos square. Cos square theta plus sin square theta equal to 1. Okay, already we have done so many questions of this nature, even in general solution. So the numerator becomes sin square theta. Sin square theta divided by cos square theta. We know that sin theta over cos theta is equal to tan theta. So here it is a square, and we get the right hand side. Prove that tan theta plus cos theta over 1 plus sin theta equal to 1 over cos theta. So at a glance we find that there is tan theta on the left hand side. So we can use our identity, the basic identity, that is sin theta over cos theta. And then we have to find the LCD. LCD is cos theta times 1 plus sin theta. We simplify the numerator. Sin theta times 1 plus sin theta plus cos theta times cos theta. Okay, so that is how we simplify the fractions. Now remove the bracket. We get sin theta plus sin square theta plus cos square theta. Then we see that what we see, sin square theta plus cos square theta is 1. Then in the numerator and denominator, if we can cancel something, we can cancel 1 plus sin theta, 1 plus sin theta cancelled. Finally we get 1 over cos theta. That is our RHS. Cos 2x over 1 plus sin 2x. So we have a lot of scope here. Double angles are coming on the left hand side. We start with the left hand side. What is cos 2x? It is cos square x minus sin square x. And again 1, we split 1, or we use our famous identity sin square x plus cos square x in the place of 1. And what is sin 2x? That is 2 sin x cos x. We have the double angle formula on the formula sheet. Then what we can do? We can factorize the numerator and again the denominator. So there is scope for that. In the numerator we have the sum and difference. Cos square x minus sin square x can be factorized. Cos x plus sin x times cos x minus sin x. In the denominator, okay, it is a trinomial. We can factorize that as cos x plus sin x times cos x plus tan. So that is the technique we are using here. Even if we do 100 questions, there will be another new question where we have to use our own brain, how to substitute or how to replace those steps with the identities. Okay, so we cancel the numerator and the denominator. We have common factors cos x plus sin x. Then we simplify to cos x minus sin x over cos x plus, that is our right hand side. Prove that tan square x equal to 1 minus cos x over 1 plus cos x. Now in this question, if we choose the left hand side, we don't think that we can proceed further. So what we do, we begin from the right hand side. Right hand side equal to 1 minus cos 2x divided, because we have few double angle formulae which we can use here in the numerator as well as in the denominator. So we have to replace. We have three options for cos 2x. We use 1 minus 2 sin square x in the place of cos 2x, the numerator. The denominator we can use 2 cos square x minus y. Look at the left hand side, we have tan square. So we need sin square over cos square when we simplify. That's why we use the 2 compound angle formulae for cos 2x here. Then what is the numerator simplified to? We will get 2 sin square x. In the denominator we cancel 1 and minus 1. We get 2 cos square. 2 and 2 cancel. Sin square x over cos square x will give us tan square x. That is our LHS. Okay. So after practicing few questions, you will click the ideas faster. That's what I feel. So make use of the known identities and then apply them. Prove that 2 sin square x over 2 tan x minus sin 2x. So we start with the left hand side. We have scope. Sin 2x is there, tan x is there. So we use the common identities. Tan x is sin x over cos x. That is 1 mark for you. Sin 2x is 2 sin x cos x. Then look at the denominator. we have to simplify the denominator. We have 2 sin x as a common factor in the denominator. We take it out. Then inside the bracket we can write 1 over cos x minus, if you take 2 sin x outside, we are left with cos x there. Again, the bracket can be simplified, and 2 sin square x and 2 sin x in the denominator can be simplified. 2 and 2 will be cancelled. Okay, 2 and 2 will be cancelled. Sin square x divided by sin x will leave sin x in the numerator. Okay, denominator, the bracket we modify. LCD is cos x. So we get 1 minus cos square x. And we know that what is 1 minus cos square? It is sin square x. So we simplify again. See, sin x must be divided by a fraction. We have to multiply by the reciprocal. Okay, so we multiply, then sin x and sin square x can be simplified to sin x, leaving cos x over sin x. That is our answer. Okay. All right, as usual, we start with our left hand side. We have sin 2x and cos 2x there. Okay, so we can use the double angle formulae. Sin 2x is 2 sin x cos x. Cos 2x is 2 cos square x minus 1. Remember that, don't blindly cancel this 2 and 2. Don't make a big mathematical error there. Minus 1 plus 1 becomes 0. So we factorize the numerator. Sin x is common. Inside the bracket we get 2 cos x plus 1. Denominator, okay, we have 2 cos square x plus cos x. Cos x is common. Our intention is to get something common in the numerator and denominator. We can simplify now, and we get sin x over cos x, which is tan x, and that is our right hand side. Prove that. Okay, very long question here. Identity. We start with the left hand side. Okay, cos square x minus cos x minus sin square x. Okay, look at the numerator. We have cos square cos. Then let us change sin square as 1 minus cos square. So we use that identity there. Denominator, we have a common factor, that is sin x times 2 cos x plus 1. Now what we do here, we have cos square, then minus of 1 minus cos square. Minus of minus cos square gives us positive cos square. So we get 2 cos square x minus cos x minus 1. What we do? We have to factorize the numerator now. Okay, we factorize very carefully. We get 2 cos x plus 1 times cos x minus 1. Very, very crucial step. Then we notice that in the numerator we have 2 cos x plus 1, and also in the denominator. Okay, so we can cancel that. We cancel that. What we get? We get cos x minus 1 over sin x. Even now we are not up to the right hand side. What we can change now, we divide both terms in the numerator by sin x. Split each. Cos x over sin x minus 1 over sin x. Even now it is not our right hand side. Look at the right hand side. What is cos x over sin x? We know that sin x over cos x is tan x. So cos x over sin x, we will write it as 1 over tan x. Okay, and minus 1 over sin. Now we have the right hand side. Say a bit difficult question, but remember we have to expect all these type of questions. Okay, so that is the end of this video. You must now practice as many questions as possible from the metric exam question papers. You have questions and memo in the internet. Try to practice more questions. These are few tips which we can apply in this question. Okay, good luck.